let me welcome you to the second lecture of surface mining technology. We are continuing to our introduction to surface mining, and the title of this lecture is current status of surface mining. In last class we have started with the rock and rock mass characteristics. This part is already discussed this is the learning background of the course, then learning objective of this course, then learning outcomes of the course surface mining technology. These are the different textbooks and different reference books that you can see for the surface mining technology. Let us retrospect the previous lecture. In the previous lecture we understand the rock and rock mass. It is also observed that the earth crust is constructed with different types of rocks and soils. The rock mass comprises different types of discontinuities. Characteristics of the rock mass discontinuities are also discussed in the previous lecture. So, this lecture will start with the introduction to surface mining, to know the current status of the mining and surface mining over the globe, over the country, and last class which we could not cover, that is the understanding of the mineral ore reserve and resource. So, at the very beginning this part we will cover first, the understanding mineral ore reserve and resource. So, mineral is basically a solid chemical compound with a fairly well defined chemical composition and a specific crystal structure that occurs naturally in pure form. So, last class also we have discussed that the rocks are basically a composition of a number of minerals. So, minerals are having their definite crystal structures, they are having their definite chemical properties, and a number of minerals are joined together to form a rock. Now, as minerals are having the well defined chemical compositions, that means in some of the minerals we may have interest, but if the mineral is interesting, then also it is may not be possible that we can go for mining of the mineral. The reason is that in a mineral it may be possible the mineral is very interesting, but we cannot mine out the mineral, we have to mine out the rock, and what is happening in the rock, maybe the composition of the mineral is not significant enough, so that we can go for mining it economically. So, minerals are good, it may be of our interest, but a mineral does not tell that we will go for mining of the same. We will go for mining of the mineral only when the composition of the mineral or the occurrence of the mineral in the rock is of interesting and should be excavated economically. So, that in that case that mineral is called ore. So, basically ore is a natural rock that contains one or more valuable minerals, typically containing metals or economic materials that can be mined, treated and sold at a profit. So, if the material is such that excavation of the same fetch a profit to the organization, then only that can be mined, and when that is mined, that is called ore. That means, in a other word you can say, when the mineral is mined, that is called ore. So, you can say in that way also, when the mineral is found that is profitable to be mined, in that case that mineral is called ore. I think now it is clear to you the difference between the mineral and the ore. Now, let us look into the different types of minerals. This is a holistic different minerals and are given here, but I would like to draw your attention in this part. What is this? CuFeS2, this is termed as the chalcopyrite. Okay. I think here is also it is given somewhere, this is chalcopyrite. The next one which is given CuCO3, CuOH whole 2, this is the composition of these two, and this is called malachite. Okay. I think it is given here somewhere. So, this chalcopyrite and malachite, both these minerals are basically the ore of copper. That means, both of these are ore of copper. Okay. Now, ore or copper means if we carry out mining of chalcopyrite, if you carry out mining of malachite, from both the minerals you can extract copper, and this extraction technology is known to us. So, technology is known to us and the technology is economic, that means we can fetch some profit. So, if we are having a chalcopyrite deposit, if we are having some malachite, in both the cases if we extract that, if we process that, refine that, we can extract a copper metal out of this, and that can be carried out profitably. So, this is basically showing us that mineral may be different, but both can be treated as the copper ore because both of them are profitable to us. So, similarly you can find out n number of other examples are there, like say hematite. Like say hematite. And you can say pyrite. So, what is happening in hematite? In hematite it is basically oxides of iron, and this is sulphide, iron sulphides. Okay. So, this oxides and sulphides, this is not in general used to extract the iron from the pyrite, because the process is much easier and profitable in case of oxide. So, that is why pyrite, though iron is available with the pyrite, but in general we do not go for extracting iron from the pyrite. So, there are many examples like this. In general, in most of the cases we found that these minerals, metals, these metals and maybe some other cases non-metals are available either in sulphide form or in sulphate form or in carbonate form or in oxides form. These are the most common formation of the minerals from which in general we go for extraction of the metals or non-metals. A mineral resource are the rock mass containing one or more minerals potentially valuable and for which reasonable prospects exist or eventually economic extractions. This is what is the meaning of this. Suppose this is the earth crust, and below this earth crust at this place, say suppose you are having 200 tons of some 200 tons of some ore. Okay. But can it be possible to go for economic mining? The reason is that you have to take out all these materials, or only for 200 ores, this if you are taking this trouble to excavate this one, exploit this one, this may not be profitable. So, occurrence of the ore does not guarantee that it can be excavated economically. But the chances, if it is expected that there is a likely chances that this can be excavated economically, then it is called mineral resource. That means, today it may not be, we know the occurrence, we are sure about the occurrence of this one, but we are not sure about the eventual economic extraction of the same. It may be potentially valuable in the future. In that cases, it is called mineral resource. But when the mineral resources are valuable and legally, economically and technically feasible, then it is called reserve. So, the basic idea, or in one word, if you would like to tell that the mineral reserve is that, or ore reserve is that, for which we are sure that we can exploit it economically, the exploitation technology is also available with us, and that can give us a good profit, then that is called reserve. But if we know, or we are little bit sure about the occurrence of the deposit, but we are not sure about its economical exploitation, or it may be because of the technical problems, it may be because of the socio-economic problems, then it is called resource, not the reserve. So, reserve means for which we know everything and we are just going to exploit that, that is called reserve. Now, let us look into the scenario for our national scenario for the mining of minerals and ores. India is mining 87 minerals, which includes 4 fuel minerals, 10 metallic minerals, 47 non-metallic minerals, 3 atomic minerals and 23 minor minerals. These values are altered in some other sources. I have found that this source, that this is Economic Times, this Economic Times is telling, this is .nic.insight, this is telling this value. This Economic Times is telling 4 fuel minerals, 3 atomic minerals, 26 metallic, non-metallic minerals and 31 minor minerals. So, there is a change in this minor minerals part, significantly there is a change in that. So, this is the number of minerals currently India is exploiting, and you can see the total value of the mineral production. The total value of mineral production is 1,135,410 million rupees. Okay. So, this is in crores, this is in million rupees. So, that means it is significantly high and contributing to the country's economy. And let us now look into the current status. These values are available in Indian Bureau of Mines website, IBM website, these values are available. So, this is 2019-20 estimated values. So, you can see different minerals. Bauxite is basically the ore of the aluminum, chromite, gold, iron, lead, manganese, all these are, you can see this is how much quantity it is being produced. So, this 1000 tons it is expressed and its values are given at this position. So, by this way, if you see, these are the metallic minerals, these are the non-metallic minerals, which includes diamond, garnet, limestone, magnesites, phosphorite and all others including graphite, kyanite, and these are the minor minerals. Some of the minor minerals are expressed here: marl, molding sand, salt. So, these are the minor minerals, and the total production, these are given here in this column, total production, and this is the value of the production is expressed here. So, you can see this is in rupees crore. So, this is the total rupees crore, how much the excavation is carried, how much mineral is excavated here is basically explained in this figure. So, if you look into this, the India is not far behind, and international standards are shown here. So, if you are considering India is stand 5th for the bauxite, 4th for the chromite, 4th for the iron ore, 7th for the manganese ore, and these are the different industrial minerals, and this is metal wise different positions are given. Now, if you see our maximum production, if you look into this, the maximum production obviously in India we are having the aggregate stone, sand and aggregate. Sand and aggregate, this is ranked 1 production wise, almost 1 billion tons, more than 1 billion tons of sand and aggregates are produced every year. The next mineral which is produced is coal, which is a fuel mineral. Approximately 700 million tons of coal is being produced. Third, iron ore. Limestone. This is more or less ranking. You can see it is almost 300 almost 200 million tons we are producing iron ore. 200 million tons of iron ores are being produced every year. So, this is the ranking country India's production of the different minerals produced in India. This is almost greater than 1000 million ton. If you look into the leasehold area, if you are looking into the leasehold area, you will find out the total leasehold area is total leasehold area is 3,25,000 hectare, and this is the number of leasee. This shows in India around 4,000 mines are under operations, and these 4,000 mines are approximately 3,26,000 hectare. 1 hectare means 10,000 square meter. So, this much of area is occupied by these mines. So, this is showing that the volume of mining is carried out in the country, and we have already observed that the economic impact of mining in the country is already observed. Now, let us look into the coal mining of the country. This is related to only the fuel minerals. So, this is for the fuel minerals. We are having 4 fuel minerals, major is coal, lignite, natural gas and crude petroleum. The coal, we are having 571 mines under operations. In underground we are having 314 mines, 216 mines are there which are operating in the surface, and there are 41 mines which are operating both in underground and open cast mines. So, this 41 is included here also, in this place also. So, there are total number of coal mines is this. The total million ton production, coal production is 604 million tons. From underground the production is 64 million tons. For the open cast production is 540 million tons, and while the open cast mining is carried out, obviously the waste rock which is covering the coal, that rock has to be handled, and this is the 885 million meter cube of overburden are also being handled for this open cast coal mines. So, now from here I draw your attention that 314 underground mines are producing only 64 million ton, whereas 216 surface mine is producing 540 million ton. That means, on an average 2.5 million tons are being produced by each surface mines, whereas the average underground mines are producing only 0.2 million ton. That means, 2 lakh tons of materials coal are being produced from the underground mines. We are also having 17 lignite mines. In this 17 lignite mines, we are also getting in the similar rate 46 million ton. That means, again that 2.5 million ton per mine we are also observed here, and all these lignite mines are the surface mine. There is no underground mine available for the lignite mines, and this while these lignite mines are producing 46 million tons of lignite, simultaneously they are also handling 181 million meter cubes of overburden. So, that means, only if you are considering coal mining, we are almost 650 million tons of coal are being produced, and only 64 million ton is from underground, and almost 590 million tons are produced from open cast. And that is why you can see open cast mines means surface mine. You can understand why this surface mining technology is very, very important. So, surface mining technology is basically producing the majority of the production. That means, almost 90% of the coal is being produced from this, and more than 90% of the material is also produced from the non coal sector. That means, the metallic, non-metallic mines also producing. So, amongst, if you are considering total mining production in the country, so more than 90% of the total productions are coming from the surface mining only, and you can understand that is why the surface mining technology is basically the main mining technology which are governing the economy of the country. And you can see, while we are producing this much of our required material simultaneously we are also handling this much quantity of the overburden rocks also. So, the excavation has to be carried out for almost 2 times or 2 to 3 times of the production being carried out in the mine. So, that is why you can see these volumes are very high, and that excavation has to be planned, has to be practiced in the mine. We are also having some production from the natural gas. This is 30,000 million meter cube is almost natural gas are being produced, that is through the well, drilled well, and petroleum, crude petroleums are also produced around 31 million tons from our different oil, crude oil mining, whether it is in Bombay High or in the Assam field, in from different petroleum mining sectors, it is being excavated. Now, let us look into the employment status, how much employment is being generated by the surface mining. This is carried out only for the coal sectors, other sectors data could not be collected. You can see the manpower deployed for the underground is this much, say almost 2 lakhs you can say. For open cast it is half of that, almost half of that, and it is surface. Now, let me define you about the surface. Surface means these are the mining workers, those who are carrying out mining. Surface workers means the office people, those who are in the surface. For underground, the timekeeper, for the safety people, or for the plant people, those who are working in the surface. This is the considerations of that only, or the magazine people, these are considering in the surface. So, this is the employment. You can see almost double employment is there for this small production, but with the half of that this much is being produced. That means, surface mining, it requires less manpower, but it generates very high, and this is also very important aspect for the surface mining technology. In lignite, you can see only 10,000 people are deployed, and that is giving 46 million tons of lignite. So, this is very important. So, basically surface mining technology is a machine driven, high mechanization is observed in these cases, and that is why you can find out the production rate is much higher with a little bit of manpower deployment. That means, production rate means the material produced, tons produced with a particular specified time, maybe hour or maybe day, maybe year. So, production per year. So, this is production per year. Now, the second term I would like to introduce to you, that is called productivity. Productivity depends on the production rate you have achieved per unit employment. So, the production rate which you are achieving per unit employment, that is productivity, is also very high in case of surface mining technology. So, surface mining, you are having high production rate, you are having high productivity, and that is why surface mining is very popular mining system in the, not only in the country, in the worldwide. So, surface mining is very popular. We can see its economic, effect onto the country's economy, country's growth. Surface mining technology, that is why is considered as the prime technology or the need of the time for the growth of the country. So, let us see some of the important or some of the notable mines. This is the first mines. This is the largest surface mine available in the world. This is Bingham Canyon mine. currently owned by the Rio Tinto. This mine is operating at 1200 meter depth. It is using 43 cubic meter shovel, 225 tonner dumper, and the leasehold area is 7.7 square kilometer. So, this is the photograph of the mine. You can see the operations of the mine. This is the deepmost mine. This is the deepmost mine of the world, surface mine of the world. If you are considering the Indian context, then Gebra is the largest mine. Gebra is the largest open cast coal mine, which is also working with 43 cubic meter shovel, 150 tonner dumper, and its current operating depth is 220 meter only, but you see the leasehold area is much higher than the Bingham copper mines. 19 square kilometer is the leasehold area. So, this is very big mine. In fact, this is the largest mine of the Asia also, and you can understand its yearly production is 43 million tons of coals are being produced by this. This is a small video related to the surface mining. I can show you the different surface mining machine. You can see this machine is called drag line. This is the drag line, which is having a wire suspended bucket. This is dumper, which is carrying out the material. You can see this is 240 tonner dumpers, which is operating here. This is the water sprinkling system. This is the excavator. You can see the shovel or excavator, which is basically taking the material and loading onto the you can see this is the explosives are used for carrying out blasting. You see this is a very big chunk of rock mass is being blasted using explosive. Okay. So, this is more or less the surface mining technology. We will learn this technology one by one in our future lectures. Now, let us have some little bit idea about the notable mines of the world. This is second deepmost mine, Chiquikamata, that is also on copper, 850 meter deep. This is Udachny of Russia, diamond mine. This is one of the very deepmost mine. This is gold mine, Uzbekistan, 600 meter, and Germany is having, this is the deepmost coal mine of the world, that is they called it brown coal, that means lignite of Germany. And some of the big machine you can see in this figure, this is the largest machine of the world, 220 meter long, 960 meter high, and 13,500 tons of weight. This is a bucket wheel excavator, which is termed as the largest machine of the world. This is some of the important figures related to Indian mines. This is, you can see the Bina mines is the deepmost mine for the country, and Malajkhand is a big project. Gebra, Bina, Deepka, Gebra and Deepka, these are 40 million tons projects, and we are having, you can see this is the photo of the largest drag line, which is having 100 meter boom and 170 cubic meter bucket, and this drag line name is Big Muskie. So, this is more or less related to the current status of the surface mining, and I wish that you will look into the web sources to get more videos. You can observe more video related to surface mining, different operations of the surface mining, that will give you a brief idea and related to surface mining technology. Thank you.